All right, everyone, let's get started. So welcome to ECE 5307. I am Professor Schneider. I'll be teaching the course. And what I wanted to do today is just go through two sets of slides. The first is more or less summarizing the syllabus, describing how the course will be taught and all that. And then the second is just a brief introduction to machine learning. And then we'll get into really the first material on the next lecture. So just to start off, so like I said, I'll be teaching the course. We decided to have office hours remotely, for now at least, because of the pandemic. So I'm going to be having office hours Thursdays, 2 to 4 p.m., and here you can see the address. You can also find this on the syllabus as well. And then there's going to be two different TAs for the course. Mohammed, he's going to be grading the labs, and he's going to be holding a whole bunch of office hours, as you can see here, Wednesday night, Thursday afternoon, evening, as well as Friday morning. And then Divya is going to be grading the homework, and she's not going to be holding office hours, but if you have a question on grading, you can ask her or me about that, about homework grading. Okay, so basically the objectives of this course is understand what machine learning is, and we're going to be covering several topics within that: regression, classification, clustering, dimensionality reduction, a bunch of other ones too. We'll learn more about what those mean a little bit later. And then there's sort of two sides to this. There's understanding the mathematics and the ideas behind machine learning, the concepts, and then second is learning how to implement these things with standard tools. So we're going to be using Python and all sorts of different packages within Python, and we're going to be using GitHub as a way of turning in labs, and as also for me to put demos out there for you to easily view and so on. I'll tell you more about that in a moment. So prerequisites, if you're an undergrad, you have to be an ECE major. If you're a grad student, you can come from any major. But I'm assuming that everyone has had calculus and linear algebra at the undergrad level, and also probability and statistics, the undergrad level, and some sort of programming. You don't need to know Python. This course will teach you Python if you've never seen it, but you do need to have some experience coding something like MATLAB or C or C++ or something like that, because we'll be just getting into the Python pretty quickly. These are some of the courses if you're an ECE student at Ohio State, but if you're a grad student, you may be coming from elsewhere, and you may have taken other courses. So this is officially an in-person course. So as long as we can do this in person with the evolving pandemic, I'm going to lecture here every Monday, Wednesday, Friday. And so here I wrote attendance is expected. Of course, if you have issues with quarantining or something, don't come to class, stay at home. I will be recording all the lectures and then posting them on YouTube. I haven't done the YouTube version of that, so this is my first time with that, so hopefully everything goes smoothly. You'll also find lecture PDFs like this one posted in advance. And a lot of our lectures will have blank spots for you to fill in, and I find that works better because if all you do is sit back and don't do anything, it's very easy to zone out, fall asleep, whatever. But if you're actively engaged in writing a few things down, it helps you to stay engaged. So a lot of lectures will have blanks where the equations are, and so you're going to have to just write that in. But also you might want to write a lot of other notes in the margins. So please, when you come to class, bring a copy of the lecture either on a tablet or in hard copy or however you want to take notes on it. And another thing that I find works pretty well are Karman discussions. So for every homework and every lab and a few other things like lecture, project, and so on, I've created a discussion on Karman, and it's a discussion that anyone can post to. And I find it's really helpful for homeworks and labs especially. So like one of you might be facing some weird issue with your lab and you'll post like, hey, is anyone seeing this? And it's some weird issue that like I've never seen. I don't know how you got that. It's very difficult for me or the TAs to figure out what's causing it, but maybe some other student has come across that as well, and they'll be able to quickly say, oh yeah, this is what the problem is. So the discussions, hopefully you guys can be active and involved in them. Same thing for homework. If there's a question on any, you read a homework problem and you're not sure what it's asking, don't send me an email, post to the discussion. If you send me an email, I'm just going to say, can you please post that to the discussion? That way my response goes out to the entire class, not just to you. So everyone can learn from each other. Okay, next, grading. So there's going to be a weekly analytical homework, just this regular derivation style homework. These are going to be due Fridays in class. There's going to be a weekly coding lab. Those are going to be due Fridays at midnight. There's going to be weekly Carmen quizzes. These, you have 7 minutes to do it. It's just 5 questions, multiple choice on Carmen. Super easy to do. Those are going to be due Fridays at 3 p.m. There's going to be 2 midterms, like analytical style midterms. Tentatively, the dates are February 18th and April 1st. And there's going to be no final exam, but there's going to be a final project. It's going to be coding based. And that is tentatively due the very last day before finals, last day class. I'm not going to give you letter grades for any of these things. You're just going to get a numerical score. Finally, at the very end of the semester, I'm going to take your cumulative score from all of this and I'm going to map them to letter grades. So they will be curved. So if you're getting an 80% and you're freaking out because you think you're going to get a terrible grade, well, 80% might be the top grade in the class. So don't fret too much about the actual number. There's going to be histograms posted, and you'll be able to see where you stand relative to the rest of the class. That's what's important because that is what will determine your final letter grade. Undergrads will be curved differently than grad students. So like I said, there's going to be a final project. The final project, the goal is to apply machine learning concepts that are taught in this class. I'll be giving you a data set and a design objective. I won't tell you where that data set comes from because the thing about machine learning is you don't really need to know where the data comes from. You learn from the data itself. So you will apply what you've learned in this class to try to implement the best solution to the problem. And there will be an in-class Kaggle competition where you guys will compete against each other to see who can do best. And you'll be able to see where you are, where everyone else is. And I found this is really fun. The students really love this. It's a great way for you guys to motivate each other. And so that's what we'll be doing at the very end of the term. These projects are going to be team-based with 3-person teams. It's going to be, the task is going to be easy to split up into 3 different pieces. You guys are welcome to just work on your piece, or you're welcome to collaborate among the 3 of you if you want. If you have people you want to join up with to make a team of 3, that's great. I'll let you do that. If you don't, if you feel like you don't know anyone in the course, that's fine too. We will take the people that are unassigned and we will create teams from you all. We won't be doing this until several weeks from now, but keep that in mind. And what you'll turn in for the project is Python code and a written report that describes how you did your design and all that stuff. So there's a bunch of optional textbooks for this course. You don't need any textbook. My notes will be enough. But these textbooks, most of them are free or nearly free. So this first one is a great, slightly more theoretical textbook. It's written for statistics students, so unfortunately it's not Python, in statistics, they use a language called R. So that's not going to be useful, but the concepts are described really well. There's this book that people have told me they like. This book is just a really great summary of Python commands, but it doesn't try to describe any kind of theory or concepts about machine learning. This next book here is great. It is a great blend between concepts and Python. But once we start doing deep learning, we're going to be using a package called PyTorch, whereas this book uses a different package called TensorFlow. So finally, this last book here is Deep Learning with PyTorch. This is another free text. This one is just all about PyTorch. And like I said, you don't need any of these books, but sometimes students ask me to recommend other books. So here's 4 books that I could recommend. All right, so we're going to be using Carmen Canvas for a lot of things in this course. For announcements, so make sure that your Carmen Canvas notifications are enabled. You can click any green links you see in my notes are hyperlinks. You can just click on them and they'll take you. So if you click on this link, it will take you to a page that tells you exactly how to do that. Like I said before, these discussion boards, I'll be posting homework on Carmen. Now, here I wrote PDF submission. So actually some of this stuff I wrote when we were doing this virtual. So we'll be turning in our homeworks in person here unless the situation changes with COVID and if we have to go back fully virtual. I'll also be posting links to the lab on Carmen, but as we'll see, turning in the labs will involve GitHub, be using Carmen for quizzes, for exams, but again, not for PDF submission. We'll have our exams here in the lecture room, assuming we can. But I will be posting solutions and histograms, final project, be giving you guys instructions, and of course, all your grades you can find on Carmen. Now, for machine learning, there's I guess you could, I'm trying to think of what to call it. It's not really a software package. It's more like, it's a website and a whole way to share code, to work on code collaboratively, as well as release code to the public, called GitHub. And we're going to be using GitHub to, I'm going to post all the lecture PDFs. And so again, this was, if we need to do Zoom recordings, well, okay. Like I said, I used to do this with Zoom. Now I'm going to try YouTube. We'll also be posting demonstration code on GitHub. And what's nice about GitHub is it renders the code in a way that you can see, whereas otherwise you need to run it on your own machine. For labs, we're going to be submitting labs through this, through GitHub, and that's going to give the TA an easy way to run all your labs. Carmen does not have a good way of handling code. So that's one of the main reasons we have to use GitHub in this course. Same thing for the final project. You're going to be submitting code. You're actually going to have a group. All of you guys will have access to the same code. You can use GitHub to work collaboratively on your code, and then when you're done, submit it up to us, and then we'll grade it. So this is the primary course repository on GitHub. Now, if you click on this and you haven't set up access, it might say like the page doesn't exist. What you need to do is you need to get access. There's a few steps that I posted in some Carmen announcements. Once you have access, you'll be able to get on there. You'll be able to see the lectures, demo code, a lot of other stuff, a lot of other instructions for how to do all sorts of stuff. And like I said before, one of the nice things about GitHub is that you can view the code. So we're going to be using something called Jupyter Notebooks. Jupyter Notebook is a Python thing that you can see the code in little blocks, but you can also see graphs and text and so on, and it's all mixed together. And it's a really great way to prototype things, to learn from people's examples, because you can put in all sorts of nice comments, figures, and all that. So, so the thing about Jupyter Notebooks is through GitHub, you can view them directly. But if you have a Jupyter Notebook on your computer locally, you actually need to run Jupyter to see it. So GitHub gives us a kind of shortcut to viewing Jupyter Notebooks. Now, if you do actually want to run or modify code, you're going to have to bring that code from GitHub down locally to your machine. And we call that cloning and pulling. And once it's down on your machine, then you need to run some Python stuff. For that, you're going to have to make sure you have installed this Python software on your machine using what I recommend is this Anaconda package. And then you'll be able to do that. You'll need to do that for all your labs and for the project. And if you want to run any of the demo code. In GitHub, each of you guys will have, for every lab, you'll have your own private repository that only you and the TAs can see. No other students will be able to see it. Once you go to the project, you'll have a repository for all your group members and the TAs to see. How many of you guys have heard of GitHub? Okay, cool. Almost all of you, that's great. All right, so Python. So why are we using Python? It's a very general, very powerful language. It includes many machine learning libraries, especially for deep learning, and it's free and open source. So in contrast, MATLAB, which is very popular in ECE, is not free and open source. It does not have many machine learning libraries, and it is not nearly as general and powerful as Python. So that's why we don't use MATLAB. Now, as I said before, no Python background is assumed. We'll teach it to you, but you do need some basic programming experience like C or MATLAB. And if you have any experience with object-oriented programming like C++, that will also be helpful. That primary course repository on GitHub has tutorials on the basic use of Python and NumPy, which is the numerical linear algebra package in Python. It also has links to moving from MATLAB to Python. So if you feel really comfortable in MATLAB and you want to know, like, well, okay, if I do this way in MATLAB, how can I do it in Python? There's a nice web page where someone has written for a MATLAB experienced user how to move to Python. And in the past, some students have also requested that I put up practice materials for those who want to just get practiced in Python and NumPy. And so there's links to that. Those are totally optional, but if you want them, they're there. Okay, so how will you run Python code? You have to get that into your computer. So we're going to be using Python 3 point whatever. We're going to be using extensively. These are NumPy is the linear algebra library. scikit-learn is the main machine learning library. Jupyter Notebooks will be our way of writing code and sharing code with each other. And later in the course, when we do deep learning, we'll be using PyTorch. So you can run Python on in the computer labs on campus or your own machine. Don't worry if you feel like your machine is slow, that's okay. We're not going to be doing any really numerically intensive stuff for the labs or the homework. Maybe once in a while, you'll have a lab where something needs to run for 2 minutes, but it's probably not longer than that. Now, if you do want more processing power, there are ways that you can do this in the cloud, and there's a bunch of resources here. These services give you a certain amount of free time in the cloud, and then at a certain point, if you use that up, you have to start paying. It's not that much money. It just really depends on how computationally intense you get. But some students find this stuff useful for the project. All right. So here's an example of a Jupyter notebook. As you can see, there's portions with text, there's portions with code, text, code, and so on. The output of the code, graphs and all that. So it's a really nice way of just reading through and understanding what's going on. You'll see already I've posted a couple demos on the main GitHub repository, just introductory material for how to get started with NumPy. And then there's a slightly more advanced introductory demo on NumPy's axis and broadcasting features. We'll be using these a little bit later in the course, but it doesn't hurt to learn them now if you have time. So that, like I said, is kind of a summary of just the syllabus, the nuts and bolts of the course. No material yet. Are there any questions on anything I've said? It's a lot of information, but no questions? All right.